Okay, and try to share my screen. And maybe we can use uh, Microsoft Word to write the answer. Okay, so just you can open the exercise from um, lecture slide, lecture PowerPoint week 6, yeah. And please find the problem from page 18. 18, right? Yes. You can read by yourself the example, okay? But I think we will discuss about the similar thing from the exercise. So please read yourself the uh, page before 18. Okay. So first, it's given x and y. It said here that given x and y be both discrete random variables with PMF or probability mass function is defined like this, right? So we know that if it's defined like this and it's a PMF, you can verify that it satisfies two properties, right? The first one is the function value is never be negative. And the second one is the total probability of this function for whole x integer number, since x and y are discrete random variables. You can verify it equals to 1. Okay, and what we need to determine here is we need to determine what is the marginal probability function for x and marginal probability function for y, which is I explained to you last time. Since the function is pxy, right? This is pxy, the name of function. Maybe we can denote the marginal probability function for x is the function that depend only of x, right? Which we can obtain from summation of this function through all value y. Yeah. So this one is maybe we can denote as p. Yeah, p only depend on x, right? And this one, right? So we need to find what is the marginal probability function for x and also for y, which is the function that depend only y. Okay. And we also need to verify or check whether x and y are independent and also calculate what is the covariance between two random variables. Okay, snipping tools. Okay. If you have any question regarding the topic that I explained to you in the class last week, so please you can interrupt. Yeah, we can discuss here. Okay, so number one, point A is we need to find what is the marginal probability of x, which is pxy. Px is depend only y. This is the marginal function, and we can compute as for all. We can take summation for all y, right? So we take sigma or sum. I want my sum here. Some symbol, this one, right? So since we have a non-zero function value for y, only for y equals to 1 and 2, so you can also write this one is for y equal to 1 to 2, right? And this is for p x comma y, which is the name of the function is pxy, right? Like this. This one, this is the definition, right? For the marginal function of x. And for the marginal function of y, it's similar thing we have, but the function should depend only y. And this is y, right? and we should take the function all over the sum for all x, right? This one, right? So this equal to just take a substitution. This is p, so x, just let it be x, x comma 1 plus x comma 2, right? And for the marginal function of y, since y non-zero for y, f non-zero for x, we take summation for x, right? It's for x from 1 to 3. So we can write like this. Keep y, but we get through x equal to 1. Okay, x equal to 1, 2, 2, 3. Okay, so just substitute, just make this formula, right? Substitute to this formula. This one should be, the divider is 30 here. Okay, so we get, I think 1 over 30 just a constant, so you can take out from sum or sigma, so you can get this one, right? And this one is just let x be like this, so x times y equal to 1, so 1 square, right, plus xy square is a x plus a plus times 2 square, right, which is equal to 1x and 4x, so you will get x, right, 5x over 30. So this is the function for x marginal, for marginal x, and the similar thing for y, you will get 1 over 30 1 over 30 for this function, right? So this function is x y square. So we x change, but y just let be a variable. 1 times y square, right? Plus, this should be 2, right? Plus, this should be 3. And you will get 1y square, 2y square, and 3y square. So you will get 6y square. 6y square over 30. Okay, so this is the function for marginal, and don't forget to put what is the function value for x. This is for x equal to 1, 2, 3, right, only. And this one also for y equals to 1 and 2, right? That's the marginal functions for x and y. And the third one, point C, we are going to verify our x and y are independent. So independent definition, or two random variable, or two random variables to be independent. It must be satisfied. The joint probability will equals to the multiplication of each marginal function, right? So I can write like this: Vxy xy exactly equal to this one, right? It's c dot or times. That's the definition, right? This is the same thing when we discuss about even as a set, right? So we have if if so we have if A and B are two independent even. Remember this, right? Then the joint probability, right? P, the probability of A uh, cap and B equals to P A times B, right? This is similar thing, right? The thing that you know before when we see the event as a set, so it's also satisfied in the context of random probability, right? A random variable, I mean. Okay, so the thing that we need to check is this one, right? So we have this, we can start from this, right? And verify if the multiplication between these two equals to this one, right? So this one is this one, right? Times py, the marginal y, and this equals to apa? This is 30, right? 5 times 6 is 30, so we get 1 over 30 from this one, right? It's the one here is cancelled by 5 times 4, and we get in this one is x y square, right? Which is equals to pxy here, right? And this is equals to p, the joint probability, px and y, right? So confirm, confirm, confirm that x and y by the definition of independent, they are uh, independent. Yeah. Okay. And the next one is point B. We need to find covariance of xy. So covariance of x and y. What is the formula? Remember the covariance formula is quite close or similar with variance, right? But variance is actually the covariance to itself, right? So this is the formula for covariance, which is the expectation of xy minus expectation x, expectation y, okay? So expectation x mean, right? So the average of x is expectation x, and the average of y, which is the expectation of y. So we get the formula for covariance is the expectation of xy minus expectation x times expectation y, right? So this is the formula. So from this one, we need to check, or we need to find or determine what is the expectation xy, expectation x, and expectation y. Okay, so for the expectation of x, okay, xy, xy, yeah, as the operator, this is the operator expectation, right? So we will get and it's a joint distribution function. So we will use the double sigma here, double sum. Okay, and this is for all x, this is for all y, and we know that we can just write for x and y which resulting non-zero value, right? So x is from 1 to 3, 1 to 3, and y is for uh, 1 to 2, right? And this one is the xy, right? Whatever inside of the operator. So this is xy, right? Times the joint probability, right? So the joint probability is p xy. That's the formula, right? Right? And we can copy, okay, xy here, and put the function here is equals to xy square over 30, right? Xy square over 30xy square over uh, ish over 30. Okay, and it give us, so we can take the constant 1 over 30 out of the sum, right? And okay, okay, and this to be x square y to the power of 3, right? I think I want to make it slower. So this one is x square times y to the power of 3. Okay, and this one is 1 over 30, and we get what? We get for x equal, let's just start from y equal to 1, right? Y equal to 1. So I want to copy this. Okay, y equals to 1. So it's for x equal to 1 up to 3, right? So we have this summation. Okay, I forgot which one y and which one x. X and y. So let y to be 1, and this one is we change into 2 for x equal to 2, right? It's, and this one is for x equal to 3, right? And next we have, okay, I want to make it like this. This is for y equal to 1, and we have for y equal to 2. It's similar thing. I just gonna copy the first row, right? And change dy, which is this position, right? Y to be 2. This one, this one, right? That's all, right? And this equals to, okay, uh, oh no, so bad like this. Maybe we can use, okay, Excel to help for calculator. Okay. Okay, so this is for x, this is for y. X is from 1 to 3, 1, 2, 3, and y is for y is 1, 2, right? 1 and 2. Maybe, okay, 1 and 2, right? 2, 2, right? Okay, I can write this table, right? This is for whole possible pair of x and y, right? So this is for x equal to 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, and 3, 2, right? This whole possible value for the pair of x and y. And we have this is pxy. Pxy just, what is the formula? I forgot. Xy square. This is equals to x times y square, right? Divided by over 30. Okay, so this is the value, right? And just check sum. This is the value of this. Okay, so this is the expectation xy, right? Hey, hey. This is pxy, and the thing that we want to calculate is expectation x. Sorry, expectation of xy. Okay, so this one is uh, equals to x times y, comma pxy, right? You can also calculate like this. It's similar thing with the thing that I write as a formula here, math formula, and just take sum of it, right? So this is the sum of this one. So this is the result, 4.2. 4 point, comma, 4.2. Right? So this is the answer for expectation x. And so for expectation y, I mean, this is for expectation xy. And so for expectation x, since we have the joint function, you see, actually this function also satisfied, should satisfy this one, right? Since we have only x in the operator, so this one is x times pxy, right? But you see here, the sum here can exchange, right? So let me exchange this. We don't need to exchange actually. How to say, yeah. Is it correct? Pxy, right? Okay, let me show you something, right? Okay, so this is the definition of expectation x. Okay, and you see what is pxy? Pxy is xy squared over 30, right? Xy squared small y. Hold second, we let. Iya, Pak. Oh gitu, Pak. Oke, Pak. Oh, ada perubahan ya? Oh iya, ya, Pak. Nanti saya konfirmasi ke Bu Mira. Yang Wahyu itu akhirnya gimana jadinya ya? Oh, second. Ah, Okay. Um, okay, so we get this one, right? So expectation of x, this one, right? It's good to be, um, I forgot where did, okay, so this one is, to the, offer, I mean, divided by 30, right? Oh, no, divided by 30 here, right? Here, ish. Okay, so this is, and we have, we can change this, sum. Actually, I'll show you something. This is for x start from 1 to 3, right? This is for y start from, 2, right? So we exchange the sum order for x and y here, and we actually don't need that, right? And okay, that's fine. So this equal to, since this is the sum over y, right? So x, we can take x out of the first sum here. So you can get this equals to, this one is the x square, right? X square come from this one, but we need to delete this because we take it out here, right? And this one is y square, right? Over 30, and we also take 30, 1 over 30 from, both sum here. So we get 1 over 30, right? Okay. And which one? Which one? The px. Uh, which one? Which one? Okay, so I don't know what I'm doing. Expectation of x. I forgot. Expectation of x is just the x time px, right? Or maybe I can prove it later, okay? So, or you can also take this as the sum, the single sum here. We don't need time to prove. Maybe I can do that in the class, uh, on, this Friday. Okay, so this is actually, since this one is expectation x, so this one is x, but depend only the marginal function of x. So this one, okay, px, and this is for all possible value for x, which is x from 1 to 3. Okay, this is what I mean. So to compute or determine expectation of x for, of the joint probability function, this is the original formula, right? But since we have the marginal function, so uh, you can find the expectation x by only this formula. So this formula is simpler than this, right? Because it only depend on x and the marginal function for, x, which is px. So this equal to 1 over 30. Okay, and we get, what is px? Px is the, this one, right? 1 per 6, right? Px is, sorry, px is 1 per 6, right? So it's not 130, so it's 1 per 6. Uh, so we have px is x here we have. So x times x is x squared, right? Okay, let me make it clear for you. This one is, x per 6, right? This one is x per 6, right? If you simplify the fraction, this is just x per 6. Okay, so you will get this equal to 1 over 6. So you have a x square here. So 1 square plus 2 square plus 3 square. Yeah, is equal to 9 plus 4, 13, 14. 14 per 6. Okay, so this is the expectation for x, and the same thing for expectation, not the same, similar thing for expectation y. You will get this is for y, right? And you can simply calculate the expectation of y depend only the marginal function of y here, and this is, don't forget, for y here, multiply by y, and this one is sum for y equal to 1 to 2. Okay, and this one is y, this is y to 2, right? And we get, what is the py? Py is this one, right? So we can simplify the fraction here to be y squared divided by 5. Okay, so y squared over 5. Y squared over 5. This one, right? Y squared over 5. Or it's just y to the power of 3, right? Or I don't need to change it, so you can know the process. So this one is just take 1/5 out of the sum. So we have 1/5 here, and y to the power of 3 for y equals to 1 and 2. To the power of 3 to the power of 3. So you get this one is 8. 8 plus 1 is 9. So it's 9 over 5. So that's for the expectation of y. Therefore, the covariance of x, y equals to this formula, right? Just copy this, and we get expectation x is in the decimal since we get it from the Excel. Expectation x is this one, right? Or maybe I can use times. Okay, so this equals to, okay, or you can also use Excel like this, right? Expectation x, right? It just this times this one, and take sum. Okay, it's the same we have here. 14 over 6. Okay. Okay, and so for expectation y, it's equals to y times the join probability, and this one, right? And we take some of it. Yeah, this is expectation of x, this is expectation of y, and covariance x, y equals to expectation xy minus expectation x times expectation y. Now, 0, right? It's 0, right? I think that makes sense, right? So this one is 0. When the covariant xy is 0, it means apa? Okay. When this is 0, it means that this one, we have this relation, right? Equal to this one, right? This is also indicator, one of the indicator, or actually this is implication of x and y is independent. So if we know that x and y, two variable, they are independent, you don't need to calculate this, right? This is to confirm, for confirmation. You don't need to compute the covariance because you know that if they are independent, the expectation xy will be equal to expectation x times expectation y, which is implies to uh, independence of two variables. Gitu. So if we know that they are independent, so the covariance should be 0. Okay. Maybe we have 30 minutes, 40 minutes left. Okay, not 40, maybe 50, right? 50 minutes left. Okay, the next one is this one. Okay, please try to solve uh, the exercise as many as you can. Okay, so this is for number 2. Okay, so we need to find what is K given the PMF because both of them is discrete, right? So given this PMF for X and Y, I think this should be comma here, not equals. This is comma, which is the value of X is 1 and 2 and so for Y, right? And for the pair of XY, outside of this value, it's the function is 0. The function value is 0. So we need to find what is K, what is the constant K, such that Pxy be a joint probability function. Okay. So for number A, finding the constant K. Finding constant K. Okay. And the second one, finding the marginal probability function. The C, the point C, I checking the independence of two variables, right? It is finding constant K. For P, X, and Y to be a probability function, then the total, right? The total function should be 1, such that we get take all the sum, right? This is because it's discrete, so take sum. So the sum one, I'm just going to copy from this. I don't want to write the same thing. So this is for Y, possible value for Y, non-zero. To be non-zero, function value is 1 to 2, and so for Y, for X, I mean, X also from 1 to 2. And we have here is Pxy, right? Maybe the name of the function just p. We don't need to have a subscription there. So, okay, so this one is apa? This one is k, right? Since k is a constant, just take it out of the sum. So we have k times 2x plus y, right? This one, so we substitute px to be this function, but we take k out of the sum, so it remains 2x plus y. Okay, and this one equals to the possible pair of these values for x and y. So we get k times, let me copy this. So this one is for x equal to 1 and for y equal to 1 plus for x equal to 2 and y equal to 1, right? Plus this is for y equal to 2, y equal to 2. This is correct, right? So I don't want to be confused. So just copy from this, right? This one is 2x. X is fine, right? We just change for y equal to 2. Okay, that's all the possible combination. So this equal to k times, this is 2, 3. This is 3 plus 5. 3 plus 5. 3 plus 5 plus 4 plus 6 we have, right? So this one is equal to k times, this one is 9, 15, 18. Okay, and this should be 1, right? The total function should be 1. Therefore, we obtain constant k equals to 1 over 18. Yeah. And next is finding the marginal function, and I just want to copy from our previous text, our previous answer, because it's similar. Just change the value of the variable. So this is, first we want to find the marginal probability function for x, for capital X, right? It's defined like this, and y is for all y, right? And y we have from 1 to 2, similar thing here, but this is not pxy but p, yeah, to be consistent with the given problem. And this one is px1 and px2, so we just change it. We just change from here. Is equal to px1 is, and we know that k here is 1 over 18, right? So we get the constant, take the constant out. Okay, 18 out, so we get this one, right? Just let x be a variable, so we get 2x plus y. 2x plus y equal to 1. plus 2x plus y equal to 2, equal to 1. It should be 1, right? Nah, 1. And we simplify this to be 1 over 18 times 2x plus 2x is 4x plus 3. Okay, so this is the result. This is 4x, 1, and 2. And similar thing for the marginal probability function for y. The marginal probability function for y, we get py, right? Py only depend on y, and we take all over x, and x from this function we know x is from 1 to 2, px, and this should be x1. Just let y there, let the variable y, this is for x equal to 2, and let variable y, and we get, this is the similar constant here, we take it out, and this one is just 2 times 1, right? 2 times 1 plus y, right? And we get here 2 times 2 plus y here, right? Such that we get, this one is, this is 2 plus y, this is 4 plus y, so we get 6 plus 2y, right? So we get 2y from this and this, and the constant is plus 4 plus 2 is 6, right? And this is for y, 1, 2, 1 and 2. Okay, so this is the answer for the marginal function. And next is point 3, checking they are independent. Yeah, to check they are independent, just verify the margin, the join probability equals to the multiplication of each marginal function. This one, right? Is it true, right? And so for that, we verify from this. This is equal to the thing that we get for x, right? X is this one. X equal to this one times py. Py is this one, right? This is for all combination x and y from 1 and 2. This one, right? So this equals to 1 over 18 square. Okay, 1 over 18 square of this function. 4x plus 3 and 2y plus 6. And we know that from this one is 1 over 18 square. So this we get 8y. Gimana sih hitungnya? 8xy, 8xy, right? Plus 24x plus 6y, 6y plus 3 times 6 is 18, right? Is it true? I think it's true, right? And this is not equal, this one. This is not equal to 1 over 18 to x plus y, okay? Of course, this is not equal to 1 over 18 times 2x plus y, right? Which is our joint probability function. So Since, so this is the conclusion, since the multiplication of each marginal function is function is not uh, the joint probability, then x and y is not independent or are dependent. Okay, so that's the answer for question number 2. Okay, maybe one more example, but I'm going to take the example. Okay, uh, do you know the formula for this covariance, right? This is correlation, right? This is covariance of x, y, and this is the correlation. Correlation x and y has formula like this. Actually, they measure the same thing, like a relation between two variables, but the correlation has no units, right? So it doesn't depend on any unit, and it will give you the value for any kind of x and y. The value should lies between this interval, means -1 to 1. So as I explained to you last week, so when the row or correlation 0, it means that two variables are not correlated, are not related, right? But if it's go to positive direction and go to 1, it means that they have a strong positive correlation. Positive means that when x goes up and so for y, yeah. And when the correlation goes to the negative direction and it's more close to -1, more close to -1, stronger the correlation. It means that it's negative, the correlation, but it's strong. Negative means that when x goes up, y goes down, and vice versa. Okay. I think that's all. What I just told you. One more example, right? So one more example. Let me go to the book, and I recommend you that you to also try to study from this book, textbook. The textbook is the Probability Statistic for Engineering and Scientists. It's from Walpole Mayers. You can get the topic that we just discussed in this book is in chapter 1 to 4. Okay, so from chapter 1 to 4, just to do couple or several exercise from there. Let me guide you. The chapter 1 told you about how to count the even as the sets, right? And the second one is how to count the probability. Means that it's still even as a set, but you need to count the possible discrete experiments, right? And you also will learn about the Bayesian rule. You will learn about conditional probability using Bayesian rule as a set, right? This is in chapter 2, and for 3 and 4 you will learn about the random variable concept and the probability function. Yeah, and 4 just specific for the expectation operator, which is tell you about the definition or mean or average, and also variance and covariance if you have a joint probability function. Okay. Okay, this is joint probability. You can also get in chapter 3. Okay, just go through this one, chapter 94, right? This is exercise, this exercise, right? This exercise. I think this still single random variable. This one, right? The joint probability distribution. And this is the property, as I told you, they write it as a definition of joint probability. So for the function to be joint probability, there are two at least. This is just how to compute, but there are two conditions that need to satisfy. The first one is the function value cannot be negative, and the second one is the total probability should be 1. And this is for the continuous, as I'll show you if x and y are discrete, so we take sigma. That's only the difference. So the discrete use sigma, and the continuous, instead of sigma, you use integral because the property of dense in real number. Okay, this is the marginal. As I'll tell you, this is the marginal for x because the function depend on x, right? So all the information I deliver to you in the lecture, they have here, and this book is quite easy to understand. Okay, just go to the exercise because we want to do one more exercise for continuous random variable, right? This one is discrete, right? Because x and y are integers. This one also discrete, this discrete, right? So please find the continuous one. Continuous. This is continuous. This is continuous. Continuous, right? Which one? Maybe this 3.4. 3.4. Okay. So the problem 3.40. The problem of 3.40. Okay. So a fast food restaurant operates both drive-through facility and walk-in facility. On the random selected day, let x and b, x, y respectively be a proportion of time. So it's time, right? So times usually it's continuous. So x and y represented the time. So they are continuous random variable and are in use, and suppose that the joint probabilities of this function is this one, where x and y is the continuous lies in interval 0, in closed interval 0 to 1. Yeah, and this is the formula for the function. And in here, we need to find what is the marginal probability function for f, for x. Yeah, so the definition of marginal function, let's say the marginal probability function for x. Yeah, marginal probability for x is f, right? X, right? This is the marginal probability of x. Since this function only depend on x, we can denote like this. And this, the definition of this is just, we take, since it's continuous, so we take the integral all over y, right? So this is all over y. This is for y from minus infinity to infinity. And this one is this function 2 over 3 x plus 2y. So we see that the non-zero function is this zero value, right? So the non-zero function value only lies for 0 from 0 to 1. So this one just take from 0 to 1 because the rest of it give us 0. This one, right? And we can take also the constant 2/3 outside of the integral. Okay, so this integral equals to 2/3 over, this one is the over y, right? Over y, so x is constant over y, so we have xy plus we have 2y. The antiderivative of 2y is y squared. Right. So this is, we take for y, right? Because we take the integral over y. This is for y from 0 to y 1. Okay, so this is 1 over 3 or 1/3. We have this one is for y equal to 1. Y equal to 1, so we substitute y with 1 here, so we get x times 1, right, which is x plus 1 minus something 0 here, or I can write it down for you to make it clear. Really clear. Plus 1, right? 1 square, right? 1 square is 1 minus the antiderivative for y equal to 0. This one is just 0. So this one is 2 over 3 x plus 1. That's all. Okay. And so for the marginal function of y, this is the function only depend on y, right? This is the depend on y, and we take the integral all over the x, right? With the same function here, but this is for x. And this is x, right? So we change this one also for x. It lies between 0 to 1 for non-zero value function. So we take the integral remain only 0 to 1 for non-zero, and we take the constant out of the integral. Okay, but here the antiderivative are different, right? The antiderivative is equal to this one. We take the derivative over the x. So x, the antiderivative of x is 1 over 2 x squared, right? Plus 2y. Antiderivative of 2y over dx is just 2yx. This is for x. This is for x equal to 0 to x equal to 0 to x equal to 1. Okay. Okay. A little bit messed up, but you still can understand. And this equals to this one, right? So this equals to substitute the x to 1 and also 0. And you get this one is half plus half plus 2y, right? Half plus 2y, that's correct, right? And for antiderivative for x equal to 0 is 0, right? And this give you this one, right? 2y plus only. Okay, and you may simplify this to be or for y over 3 plus plus berapa tuh? Plus 1/3, right? Is it correct? I think yeah. 2/3 times half is 1/3. That's all. This is for the marginal function of x. Okay. Uh, okay. Okay. This is for point B, right? The problem in the book is much easier usually than the problem in lecture slides, and you have more option there from very easy to quite challenging. So you can practice. I think you can. It is nice for you to go to this book and try to pick a couple or several numbers, several exercise here, and try to solve it. And the point C is find the probability that the drive-through facility, which is drive-through facility is X, right? And walk-in facilities is Y. So find the probability that the drive-through facility is busy less than 1/2 of the time. So the thing that we want to determine here is the probability of drive-through is X, right? Okay, is X less than 1/2 of the time? Less than. Okay, so this one is less than 0 0.5, right? 0.5 or 1/2. Okay. So to find this, we just need, since this one is only depend or asking about the x, so this only depend on the marginal function of x. So we can take the integral from this, right? So this one is actually equals to dx. One is over dx. Less than half means that it's from minus infinity to half, right? Of fx fx dx, right? And this equal to the same interval for the integral here. And we change or replace the fx to be this function. Okay, and we take out the constant 2/3. Okay, this one, and we take x plus 1, the integral of x plus 1. This equal to 2/3. X plus 1 is the x square, right? Antiderivative of x plus x. H. Okay. And this is for x. Okay, this is for x equals to minus infinity. And this is for x 1/3. I think we should simplify something here, right? Because this is 0 for outside of this interval. So we can simplify this to be 0, right? Start from 0. Okay, this is also from 0. And this is also from 0, and x equals to, it's okay. So just calculate it. This is equal to 2/3 times 1/2 times x squared. X, replace x by 1/2, right? Square plus half. Okay, and this is just 0, right? For x equal to 0, this function is just 0, so it remain only this part. It is equals to 2/3 1/8, 2/3 1/8 plus, okay, so this is equal to 2/3. This one is 4/8, right? 4/8, 4/5. So this one is 5/8. So you will get this equal to 10 to 10/24. Okay, so this is the answer. Okay, so this is the probability for the time, the drive-through, right? Time drive-through is less than 1/2 of the time. Yeah. So that's the answer for, or the example for the continuous join probability function. Okay, I think that's all. Before we end, do you have any question? Do you have any question? If you don't, thank you for your attention. I'll send you the link for the recording of this meeting. Thank you for your attention. Good afternoon.
Thank you, Miss.
Yeah.